Very cool. All right, so I'm going to be talking about functional CSS and applying functional programming principles to CSS. So who am I? My name is Ben Adam, and I'm a UX engineer at GoDaddy. And so if you see us like in the hall or anything like that, come say hi. I think we have a table out there. And so you'll probably have one of two reactions to my talk. Reaction number one, and potentially reaction number two. So my goal is Nick Cage. But regardless, I hope this presentation challenges you to think critically about CSS. And just as a show of hands, how many of you guys are working on a team of 5 or less? Okay, so the majority of you guys are working on teams of 5 or less. How many of you guys are working on teams larger than 5? All right, so it's kind of split. So really, this is like geared towards people working on teams, because fundamentally, coding is a social construct. We're writing code for people and then translating that so a machine can run it. But when we maintain code and when we write code, we're actually writing it for other developers. And so I want to start by kind of setting some criteria for my talk and looking at this idea of what is good CSS. So this might be a simplistic definition, but to me, good CSS is 3 things. It's simple, it's predictable, and it's fast. So if these things are true, which I believe that they are, then we can also infer the opposite is also true. So we can say that bad CSS is complex, it's unpredictable, and it's slow. So my kind of operating assumption here is that if we can reduce developer experience problems, we can focus more time and effort on building great products. So the first 2 bullet points about bad CSS and good CSS are related to developer experience, and the last one is related to user experience. And all of us are trying to provide value for our end user. And code is the artifact that we're using to produce that value. So really, users get benefit from the end product, not like looking at our source code. So let's tackle a couple of these problems. Problem number 1, bad CSS is complex. So this is Rich Hickey. He is the author of a library called Clojure, which is a functional programming library. Or it's actually a functional programming language. And he gives a really great talk called Simple Made Easy. And he talks about what makes something complex versus what makes something simple. So he likes to start with word origins, and I think this is really interesting. The word complex comes from the archaic word complect, which means to entwine or weave together. And simple, in contrast, comes from the Latin word simplex, meaning unfolded, unbraided, or unentwined. And if you do a Google search on word origins, you'll see that. So this is a good example to illustrate the difference between simple and complex. If we think of complexity as something that is entwined or woven together, we can look at this castle here. And if we're building castles and we need to add a new tower to our castle, which castle would we rather be working with? All right, I've already hit my recording limit. I'm sorry, we'll have to fix that later. In contrast, we have this Lego castle, which is really easy to take apart. And basically, its simplicity comes not from what it is that it's trying to build, it comes from how easy it is to take apart. So you can take things apart and put them back together with relative ease and recompose things, whereas with the knitted castle, you're going to have to untangle that whole thing in order to make any changes to it. And I think that this is really germane to our just thinking about code in general. We can start thinking about complexity as how much of our code base is woven together. How many parts of our code need to know about other parts of the code base? And the more parts that are dependent on each other, the more woven together that they are. So how does CSS become complex? Well, over time, code has a tendency to grow. And this is because we're adding new features or we're adding new team members. Both of these contribute to our code base growing. And in CSS in particular, developers, especially as your team size grows, are not always aware of the full scope of your CSS code base. So they might not, you may have written a class for something, and another developer comes in, maybe a new employee, maybe someone on a different team that's also working on your product, is not aware of that class that you wrote, and so they're going to probably add more code. Another reason why it becomes complex is because existing classes don't do exactly what we need them to do. So we either extend them or we override them or we do something to it. But at the end of the day, the solution is typically add more CSS. And so over time, this can become really nasty. So just as a general principle, I believe that it is much easier to write new CSS than it is to delete or refactor CSS. And this is what makes CSS so difficult. A lot of people talk about, well, CSS is really hard, and people that are experienced with CSS would say, no, you just don't know CSS. But I think this is the nature of the complexity of CSS, is that it tends to grow over time, and it's really difficult to prevent it from doing that. So looking at problem number 2, bad CSS is unpredictable. So if you guys have worked in a large CSS code base, you have probably experienced this before. I'm just going to change this one thing, and it's going to be great, right? So yeah, this is refactoring CSS in real life. So what makes CSS unpredictable? CSS has a global scope, so every class, every element selector, every ID selector is available across the board, so it can target everything. There's no scoping in CSS. Also specificity in the cascade. So specificity is how CSS determines which style takes precedence when there's conflicting styles, and those conflicts come from the global scope. So specificity is based on a scale. And so this can become unpredictable if we're not really sure of how much specificity something has. Also, CSS has a little bit of a quirky inheritance model. I've worked with CSS pretty extensively, and I can definitely not tell you all of the properties of CSS that are inherited. There's a lot, and I don't have them memorized. So I can't look at something. I mean, with certain cases, I can look at something, but in a lot of cases, something may inherit, and I wasn't aware that it was an inherited property. So not to troll on Twitter, it's probably my favorite digital product, but I'm going to troll on Twitter for a little bit. So this is the CSS stats for twitter.com. So if you go to cssstats.com and type in a URL, it will give you an output of statistics about the website that you're looking at. And so this is looking at their CSS in particular. So a few things that we notice here is that it's 642 kilobytes, which is pretty massive for CSS. Other observations is that there are 172 unique CSS properties, but there's 17,000 however many declarations, which means that there is a lot of property duplication. So you can start to see this, that the float property, which has 5 potential values, is declared 281 times. So that means they're declaring float over and over and over again within their CSS. And as you can see, these declarations here are showing you how many times the same property is being used and duplicated. And this is the specificity graph for twitter.com. So as you can see, you have these huge spikes. And what these spikes represent is going from low specificity to high specificity throughout the cascade. And so this means that depending on where your CSS is declared, there's going to be things that are overriding it. And this is unpredictable because this is a relatively large code base, and it's going to be really difficult to make changes without having to ratchet up your specificity to override something. So this is a great programming quote. Simplicity is a prerequisite for reliability. So this really addresses problem number 1 and problem number 2. If we get simplicity, then we also, as a byproduct, tend to get reliability. So how does functional programming address some of these issues? And so I feel a little bit like Charlie Day right now, bringing up a lot of JavaScript at a CSS conference, but let's roll with it. So what is functional programming? We have to go to the source of all knowledge, which is Wikipedia. And Wikipedia tells us that functional programming is a programming paradigm, a style of building structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. It is a declarative programming paradigm, which means that programming is done with expressions or declarations instead of statements. So really, at the core of it, functional programming is treating our programs like math. We want to have inputs and we want to have a predictable output. So functional programming, totally a buzzword, probably the reason why you're at this talk. But such dog, such functional, such speed, much fast. So let's look at a few principles from functional programming and see if we can apply them to the way that we write CSS. So principle number 1 is purity. A function is pure if given the same inputs, it always returns the same output. So in this example here, we have a function that takes in a parameter of x and returns x plus 1. So f of 1 would be 2, f of 3 would equal 4. And we know that every single time we pass in 1, we're going to get the same result. We're going to get 2 every single time we call f of 1. So looking at this, like, what would an impure function look like? So in this example, we have a global variable a, which equals 3. And we have a function that I named impure multiply, which takes in a parameter b and multiplies a times b. So when you call impure multiply, it's going to do 3 times 3. So why is this considered impure? Well, if your global variable gets reassigned, so later on somebody reassigns a to equal 4, when we call impure multiply with 3, it's going to return 12. Which is different than impure multiply earlier on. So this is inconsistent, and so we would consider this to be impure. So in contrast, the pure function only operates on its local scope. So multiply takes in 2 parameters, a and b, and multiplies a times b. So when we multiply 2 times 3, it will return 6, and we can test this. It's really easy to test. We can write a test that says multiply 2 and 3 and expects to return 6. So principle number 2 is immutability. In functional programming, data is viewed as immutable, meaning it should not be directly modified or overridden. So an example of this is an array. So there's 2 different ways to manipulate an array. There's an array.push, which pushes onto an existing array, and we would consider this not the way to do this in JavaScript, because it directly manipulates the original array. In contrast, we would use a concat. A concat creates a copy of the array, and then it reassigns it to a new variable. So we're not actually manipulating our data. And so JavaScript, by default, does not enforce immutability, but it's treated as a best practice. There's libraries such as immutable.js that can help you enforce immutability if you're going in a more functional programming style. But really, it comes down to best practices, which draws a correlation to CSS, which can't enforce these things either. So immutability is a constraint, and I put virtuous in parentheses here because when we look at constraints, basically a constraint is us limiting our ability to do something, and we're going to ask, like, what do we get back from limiting ourselves? So, like, do we gain benefit from limiting ourselves in certain ways? And in a lot of ways, immutability is like that. We constrain ourselves to get benefit in return. So in functional programming, this allows us to do cheap equality checks on data. We know we don't have to do a deep equality check. And so it's really performant to do equality checks. It helps our data stay in sync with the UI. And it's easier to persist. So yeah, that's looking at immutability. So principle number 3 is composition, and this is probably the fundamental principle of functional programming. And so composition is combining simple functions to form new, more powerful functions. It's basically looking at it like Legos. Can we put 2 Legos together to make like a new structure? So an example of this is we have 2 functions here. We have double, which takes in a parameter of x and returns x plus x, and then square, which takes in a parameter of x and returns x times x. So we can compose these functions together, and so composition takes the return value from the first function and passes it to the second function. So we call square with 2, so square does x times x, so it's 4, and then we double it, and we pass that return value 4 to double, which does 4 plus 4, and it returns 8. So this is a way of composing functions together to get a double and square function. So how do we apply some of these principles to CSS? Well, it's a little bit, it's not an apples to apples comparison, but I think that the principles of these things can be true across the board, and we can start to look at what are the virtues of functional programming, and do we need those same virtues in our CSS? So principle number 1, purity. So I'm guessing a lot of you can probably answer this really quickly, but what color is Hello World? Anybody want to yell it out? Let's see if I can make this a little bit bigger. Oh. No, there it is. Anybody want to call it out? So the answer is blue. Basically, the reason for this is blue has a higher specificity, and so blue is targeting a child that's an H2 and giving it the color blue. And even though our H2 has a class of red, the outside style wins because of the specificity. And so this happens a lot of times in our code base, based on the way that we structure our code, is even though we have intent of a certain style being applied to an element, we get a different style instead because of the global nature of CSS. So this is the speaker's opinion, so take it for what it's worth, but I would consider CSS to be pure in the functional programming sense if an element is only styled by its classes and not by globals. So I'll just let that sink in really quick. So basically, this is a little bit controversial because it's saying, hey, we don't want to use some of the core features of CSS. We're gonna constrain ourselves. We don't want to use globals in the cascade to style our elements. So principle number 2, immutability. If CSS were truly immutable, we wouldn't be able to override its properties. So we'd have to think about our CSS much differently if we weren't able to just override something by giving it a new value and a higher specificity. So how can we avoid overriding properties in CSS? And I think some of these things, regardless of the methodology that you use, are good practices. So we can keep our specificity flat by using only classes. So thinking back to that Twitter example where we see these spikes in the specificity graph, we want it to really look like a slow trend upwards without spikes, and we want it to be relatively flat. And the way that we do this is by using only classes and not using IDs, element, attribute, and complex selectors. So this is very limiting in some senses because these are some nice features of CSS depending on what you're trying to do. But really the goal is that we would have a very flat specificity so that we can have high degree of confidence that our styles are going to be applied when we want them to be applied. Again, a little bit controversial, but avoiding inheritance in the cascade. So this is to be like, if we want our classes to be pure, we don't want the global scope to really be influencing our element. We want our elements to be deterministic and say what styles they want to have. And then finally, and I think that this is really important for CSS, is we want to avoid property duplication. And so the way that we can do this is with single property utility classes. So this gets into kind of like the methodology. So this would be kind of your classic way of writing CSS. You write a semantic class name, and you would say card, gets a border, has a border radius, has a background color, and has padding, and that's what a card is. But if you notice, we actually need 2 things in order for a card to work. We need a CSS class, and then we also need the right HTML structure. And so these things are dependent on each other. And as a rule of thought, the more declarations your CSS selector has, the less reusable it is. So the more properties that we have like this, we're going to need a specific use case in order to be able to reuse this CSS and not have to duplicate our properties. So in contrast, the way that we would accomplish the same style output with single purpose utility classes is breaking them up. So as you can see, now we have a class for each property. And in our HTML, we get this pretty nasty looking class structure. But what is really interesting about this is that now these things are highly reusable. How many times do we declare border style solid throughout our code base? We're able to truly reuse this. Everywhere we need a border style of solid, we can use this utility class. So principle number 3, which kind of ties all these things together, is composition. So in CSS, like, we don't really have a way of encapsulating things, and so I work with React, and I think it's a great technology. But really, the way that you can do composition is using a component-based library. So React uses this idea of a component, and other libraries such as Angular, Ember, Vue, a lot of the front-end libraries are starting to move in this direction of a component-based architecture. And what components allow us to do is to hide the nasty class bloat so that we can actually reuse something as a package of HTML and CSS and JavaScript and actually reuse it. So instead of having a semantic class name for card, we compose these classes together in our HTML and wrap that in a component. So now we've created a card component. And then when we use our card component, now every time a card is used, we can, we get all of these classes. And so this allows us to actually reuse our classes without having to maintain this long string of classes throughout our HTML. And so components is the way that you compose these together. And so some of the benefits that we've experienced, we have a project that we're using functional CSS on currently, and some of the benefits that we've experienced is performance. So with performance, it comes in 2 factors. One is the size of the download size of your CSS. So this dramatically reduces the size of your overall CSS. And then in addition, even though browsers are highly optimized now and it's not as much of an issue, complex selectors are less performant than just straight classes. And so it uses a straight class methodology, so it's a little bit more performant in that way. Consistency. So because we're using components, we're able to hide these classes within our components and get consistent reuse every time we're using that component. And then as a designer, so I'm a designer that also does front-end code. For me, this means less context switching. So I want to be able to design in the browser, and this enables me, once we've achieved a critical mass of these functional utilities, I don't need to switch back and forth between my CSS file and my HTML file or my JavaScript file. I can use one file and I can actually start designing in the code by adding these utility classes. It reduces cognitive overload. So when you look at a card class, you don't know exactly what that means. When you're looking at someone else's HTML, you have to then go and look at what styles is being applied. And it's harder to hold the whole system in your head. Whereas when you're looking at these functional classes, you can actually reason about what the style is that's going to be applied to that element by looking at the classes. And then the last reason is it reduces the cost of design changes. So now when you make a design change, you don't have to change your HTML and your CSS, you just have to change your HTML. And so this reduces the cost and makes things easier to take apart and put back together. And so working on products, this happens a lot. We'll try one idea and then it doesn't work very well, so we have to change our design. And code bases are typically not very resilient to churn. It ends up bloating the code base in a lot of ways. And so this helps your code base be a little bit more resilient to design changes. So it wouldn't be fair for me to talk about all the benefits without talking about some of the drawbacks of this approach. So one of the drawbacks is that it's harder to inspect your styles. When you have all of these single utility classes, you can't just turn things on and off in your selector, in your inspector. So it makes debugging a little bit harder. Also, you have to look at class bloat in your HTML, which is pretty ugly. But based on all of the research that I've done, this actually hasn't, when you have a lot of classes, it doesn't actually influence your performance in a noticeable way. And then you need components for design consistency. So if you want to use this methodology, you really need components to package them up and reuse them effectively. Otherwise, you're going to try and maintain a huge string of classes throughout your code base, and that can get out of hand. So these are potential drawbacks of functional CSS. So I want to check the time because I know that we are running a little bit behind, but let's see how much time for examples I have. All right, I got 10 minutes. Sweet. So I tried to preemptively try and think through some of the questions that you guys might have, but feel free to grab me in the hall or ask them during the panel if you have further questions. But so this is probably the first question that should come to your mind is, what should I do if I'm trying to accomplish something that doesn't fit nicely into this paradigm? My answer would be pragmatic. Your code will never be 100% pure. Even if you're doing functional programming in JavaScript, chances are you still need to have side effects for network requests and other things like that. And the same goes for CSS. You'll never be 100% pure, so break out of these constraints if you need to. Get as much benefit out of the methodology as you can, and if it starts to like constrain you in a way that you no longer derive benefit, then don't use it. This seems like a lot of CSS to write from scratch to get started with. Is it worth it? My answer would be use tachyons. Tachyons is a functional CSS library that when minified and gzipped is less than 14 kilobytes. And you can go even smaller because it's on NPM, and you can require each of the utilities as a package. And the guy who wrote it did a really good job. So basically, it's all responsive by default. It has a really strong naming convention that's learnable. And basically, he did all of the work for you already. So use his library. What types of projects should I use this methodology for? So I would say if you're building a web app with a team larger than 4 or 5, this is going to give you a lot of value. If you're building with a smaller team, smaller teams, you are more familiar with each other's code. So my team at GoDaddy, I don't actually know how many engineers are on our team, and I don't know how many people are making commits to our CSS code base. But it's a lot of people, and I'm not able to like review every single PR that comes through and like police like CSS practices. So if you have strong constraints that make you think about new ways of doing things, and that we're not really growing the size of our our CSS code base, this really helps if your team is scaling. But if you're building a marketing site or like an editorial style page, like a news or a blog or something like that, the traditional model was actually designed for that. It was designed for documents. And so that's where a lot of people's struggles with CSS come into play, is that the web and the initial spec for CSS was designed for documents and creating styled documents, not for building complex web apps. And so I would say, like, if you're doing something that's more of the traditional approach on the web, like use the approach that you're comfortable with. Some of you may be thinking this sounds like a terrible idea, and actually the CSS Zen Garden guy tweeted that it was a terrible idea. So is it? My answer would be see for yourself. Lots of terrible ideas are actually challenging the status quo and moving the industry forward. And so I think if you're comfortable trying something new and evaluating it for yourself, that's really where you're going to learn the most. And whoever thought leaders are, take their thoughts into consideration, but try it for yourself. Let's see how I'm doing on time. Okay, I got a few more minutes. So how do you do nth child selection, hovers, and active states using this methodology? Because now we can't use these, funky selectors. So I'm going to be giving some examples in React. I apologize if you're not familiar with React, but this is how in my day-to-day that I go about doing these things. So this is actually an example taken straight from Tachyon's website, and he has a really great list of components that he's built with these so that you can reuse them. And so basically what's happening here is we have an array of cats. I love cats. I'm sorry if you're dog people, but don't judge me. And what we have here is basically we're trying to achieve this UI. So as you can see, these articles have some padding applied to them. So it's padding is the P, and then what we're trying to do is we're trying to give it this border style where we're giving a border bottom to each of the elements. But obviously, because our last item, we don't want a border bottom on that one, so we don't want to apply the border. So the way that we can do this in React is we are mapping over our cats and we actually know which cat is where we're at in the array. So basically what we do is we check to see the last item of the array, cats.length -1 is greater than I. And for all the ones that meet that condition, we apply our border bottom. For the last item, we basically have a ternary operator here, and we just return it without the class names on it. So this is basically dynamically choosing which ones you want to apply classes to and which ones you don't want to apply classes to. So the output here, and we can inspect it, as you can see, woo! So you see, like in the inspector, all of these got our functional class that gives it the border bottom and the border light silver, which is kind of their naming convention for this gray color. And then the last one doesn't get those classes. So basically, you just don't give classes to the ones that you don't want. And that's how you do last child. First child is basically the same approach, except that you're selecting the first item in your array and mapping over that, and basically use the ternary operator again there. And then now, if we inspect, we get, yay, we didn't apply our classes to the first one. So basically, you're deterministically applying your classes if you're creating them dynamically. So this is toggling visibility with React and tachyons. So basically, what we want to do is we have this toggle here. We want to be able to click it and make our stuff go away. And this is really, this kind of approach is how you manage like state changes, so like open and closed and stuff like that. So the way that you handle this is, again, you deterministically add the utility classes that you need. And so basically I'm defining db as display block and dn as display none. And these are the classes, and it's basically checking whether the state of show article is true or false. So if it's true, it's going to display block, and if it's false, it's going to display none. And so we basically get to experience that here, where we're referencing it. This is a template literal in ES6, where this is just applying the classes based on the state. So when we click it, it goes away. When we click it again, it comes back. And so basically this methodology allows you to define all of the classes that you need to toggle here. So if you're composing them together, you can compose them together up here, and then they'll get injected. So that's how you would do kind of state toggling. And then how do you do like active, hovers, and animations? So this is really where the paradigm starts to break down a little bit, and where you might need to break out of these conventions a little bit. Because when you do a hover, you're actually doing property duplication anyways. So you're duplicating your properties. So my recommendation is you're not going to have a ton of elements that are going to have a hover selector on them. So these are good opportunities to just put a semantic class name on it, like button hover, and then give it your hover and put all the declarations that you need to toggle on hover there. It's just easier to do that instead of doing every property with a hover state on that. That just gets out of hand really fast. Same approach for active. And then animate. You can use utility classes for animation as well. And there might be some property duplication here, but really, the point is reuse. So you can start thinking of your CSS for animation as reusable classes that if I want to animate something, I'm just giving it this class. So that's kind of how I would handle those types of situations. And so I put together like some resources and further reading on the topic. Simple Made Easy is a talk by Rich Hickey that I referenced earlier. I think that every programmer needs to watch this talk, but it really helps you think about code in a different way, and I think that that's really valuable. Scalable CSS is where a lot of these ideas kind of came from, and it's written by the author of Tachyons, which all of these are links, by the way. They don't look like it, but when I post this, these are links. You can click on them. And then building and shipping functional CSS. This is kind of a developer's reflection on using this methodology and what benefits they experience in their code base. So with that, I'm at BenAdam11 on Twitter. Send your angry tweets to me. I will respond with GIFs. And I really appreciate you guys listening to my talk.